So what you'll find here is our Rapid Plan Create and Rapid Plan Real-Time software that is being used to control 3 Mitsubishi robots, 1 cobot and 2 other robots. The technology runs on an industrial PC, and we can use any industrial PC. We have certain specs for it to be able to do the motion planning. What you will see is that we have the 3 robots doing a screw operation and then an inspection robot. The camera that you see is just for inspection. It's not required for the motion planning. What we're able to do with our software is for you to define the targets that you want to get to, and we will take care of the motion planning for you. So you just have to define where you want each of the screws, and the robots will get there. Similar to a GPS functionality, where you set your destination and it will compute the best path possible. So as you can see here, each of the robots, as they're going to move to a location, they'll block out the space. So that envelope becomes an obstacle for the other robots to work around. Again, if you need to make a change, you would change the endpoint, the targets, you would teach those, but the actual motion planning is taken care of by the real-time robotics technology. So this reduces the amount of time that you have to work on setting each point. You no longer have to do that. We'll do that for you.
So what we're seeing here are 2 Kawasaki BX robots with aero spot weld guns. And you're noticing the robots are moving very close to one another, and they're able to operate in extremely dense configurations. And our software, Rapid Plan, has been used to configure, to create all the motion planning that exists inside of the work cell. Now, with Rapid Plan, it's not just one single motion that exists for each robot. We're actually pre-calculating and pre-computing thousands of motions that each one of those robots can utilize at runtime, which opens a door to a number of possibilities like automated fault recovery, dynamic interference zone creation, run flat capability. And you'll see here on our HMI that we've developed for the show, I have a number of kind of user configurable tasks or parameters that I can use to indicate what I want the robots to do. So for example, if I pause the cell by just simply clicking the HMI, the robots stop. I can reconfigure them to go move in the most optimal orientation based on where each of the robots are. And you'll notice on the screen that clouded region around each robot. What that's doing is actually communicating the intended path that each robot's taking. If I change the motions in real time and I can rehome the robots are going to actually take a different path back to home. So each motion is being calculated and utilized dynamically. I can swap roles. So now the robots will pick up different spot weld locations in the work cell. You'll notice there that the right robot is reaching over to the far left, and the left robot is simply waiting in real time to make a move. And I have all of these parameters that I can kind of load on my work cell to unlock flexible, adaptable robotic work cells. And we specialize in spot welding, other body and white type applications, and we also do a lot of work in the digital twin in the commissioning process, actually sending motion planning into simulation software to do the same fast motion planning process.